Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss trigonometric functions. Trigonometric functions. Exercise 3.2. Exercise 3.2. In this exercise, we discuss these 3 points, these 3 concepts. Okay, my dear children. What are the 3 points? The first point is trigonometric functions, and the second point is sign of trigonometric functions, and the third point is domain and range of trigonometric functions. Okay, my dear children, are you ready to listen the class? Yes, right. In earlier classes, we have studied trigonometric ratios for acute angles as the ratio of sides of a right angled triangle. Isn't it, my dear children? Right. We will now extend the definition of trigonometric ratio to any angle in terms of radian measure and study them as trigonometric functions. Both are same. Trigonometric ratios or trigonometric functions denote the same. Okay, my dear children. So now consider a unit circle with the center at origin of the coordinate axis. See this figure. This is the coordinate axis, x-axis and y-axis. We have taken a unit circle. Unit circle means the radius of the circle is 1 unit. Radius of the circle is 1 unit. Okay, my dear children. And this center of the circle is origin. Center of the circle is taken as origin. Let P, A, B be any point on this circle with the angle AOP is equal to x radian. See, on this circle, we can take any point P anywhere on this circle. We assumed here P is a point. Its coordinates are A, B. X coordinate is A and Y coordinate is B. And this OP ray is making or subtending an angle x radians with the positive x-axis. Okay, my dear children. Angle AOP. This angle is x radians, and the length of this arc is x units. That is AP is equal to x units. Understood this diagram, my dear children? Right. We define cos x is equal to A and sin x is equal to B. Since triangle OMP is right triangle. In earlier class, you studied cos x is equal to adjacent side by hypotenuse. Similarly, sin x is equal to opposite side by hypotenuse. By using that formula, we get here cos x is equal to A by 1 actually. A by 1 means A only. Similarly, sin x is equal to B by 1. So, finally, we get B. Understood these two results, my dear children? Right. We have OM square plus MP square is equal to OP square. This is a Pythagoras theorem. In a right angle triangle, sum of the squares of two sides equal to the square of the hypotenuse. Okay, my dear children? Understood this step? Right. This implies OM square, that is A square, MP square, that is B square, is equal to OP 1. Understood this step, my dear children? Right. Thus, for every point on the unit circle, we have A square plus B square is equal to 1. Or what is meant by A here? Cos. So, cos square x plus what is meant by B here? Sin. Sin square x is equal to 1. This result, this result is treated as a trigonometric identity. Sin square x plus cos square x is equal to 1. Understood this step, my children? Right. Since one complete revolution subtends an angle of 2 pi radian at the center of the circle. Angle AOB is equal to pi by 2. From the figure we find out angle AOB is equal to pi by 2, angle AOC is equal to pi, and angle AOD is equal to 3 pi by 2. All these angles which are integral multiples of pi by 2 are called quadrant angles. Remember this definition of quadrant angles, my dear children. I repeat, all the angles which are integral multiples of pi by 2 are called quadrant angles. Understood this definition of quadrant angles, my dear children? Right. Now remember these points, my dear children. First point, sine of 2n pi plus x is equal to sin x for n belongs to z. Second point, cos of 2n pi plus x is equal to cos x where n belongs to z. Similarly, sin x is equal to 0 if x is equal to 0 plus or minus pi, plus or minus 2 pi, plus or minus 3 pi, and so on. That is, when x is a multiple of pi, if x is a multiple of pi, then sin x value is 0. Similarly, cos x value is 0 if x is equal to plus or minus pi by 2, plus or minus 3 pi by 2, plus or minus 5 pi by 2, and so on. That is, cos x vanishes. Cos x vanishes means cos x value is 0 when x is an odd multiple of pi by 2. Okay, my dear children? Understood this point, my dear children? Right. Therefore, sin x is equal to 0 implies x is equal to n pi. We generalized the above results. Okay, my dear children? Where n is any integer. Similarly, cos x is equal to 0 implies x is equal to 2n plus 1 into pi by 2, where n is any integer. Okay, my dear children? The above results are written in the general form. Okay, my dear children? Right. Now come to this point. You have already learnt in 10th class the trigonometric values, the trigonometric ratios of these common angles: 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. In radian measure, we can say that pi by 6. 30 degrees means pi by 6, 45 degrees means pi by 4, 60 degrees means pi by 3, 90 degrees means pi by 2, 180 degrees means pi radians, 270 degrees means 3 pi by 2 radians, 360 degrees means 2 pi radians. Okay, my dear children. For these common angles, we know sine and cos and tan values. Sine 0, 0. Sine 30 degrees, 1 by 2. Sine 45 degrees, 1 by root 2. Sine 60 degrees, root 3 by 2. Sine 90 degrees, 1. Sine 180 degrees, 0. Sine 270 degrees, minus 1. Sine 360 degrees, 0. You have to remember these values, my dear children. We frequently use these values throughout this chapter. Okay, my dear children. Similarly, come to the cos values. Cos 0 degrees, 1. Cos 30 degrees, root 3 by 2. Cos 45 degrees, 1 by root 2. Cos 60 degrees, 1 by 2. Cos 90 degrees, 0. Cos 180 degrees, minus 1. Cos 270 degrees, 0. Cos 360 degrees, 1. Okay, my dear children. Now, tan. You know, tan x is equal to cos sin x by cos x. So 0 by 1, you get 0. 1 by 2 by root 3 by 2. What you get? 1 by root 3 only. 1 by root 2 by 1 by root 2. You get here 1. So tan 45 degrees value is 1. Tan 60 degrees. Sin 60 degrees by cos 60 degrees. By simplifying these two numbers, what will you get? Root 3. Tan 90 degrees, sin 90 degrees by cos 90 degrees. Not defined. So, any number by 0. you can say that not defined. Okay, my children. Now tan 180 degrees, sin 180 degrees by cos 180 degrees. 0. 0 by minus 1, 0. Now come to tan 270 degrees, sin 270 degrees by cos 270 degrees. Not defined because denominator is 0. So we say that not defined. Understood this point, my children? Right. Similarly, tan 360 degrees is equal to sin 360 degrees by cos 360 degrees. 0. Remember all these values, my children. Okay. Right. Now come to the next point, that is sign of trigonometric functions. In this point we discuss the angles. If the angle is a negative angle, then what is the sign of trigonometric functions? Okay, my dear children, see this one, sine of minus x is equal to minus sin x. Remember these points, my dear children. We use these points as formulae. In solving the problems, we use these results as a formula. Okay, my dear children, remember and learn well. Okay, my dear children, memorize these formulae well. Cos of minus x is equal to cos x. Tan of minus x is equal to minus tan x. Cot of minus x is equal to minus cot x. Secant of minus x is equal to secant x. Cosecant of minus x is equal to minus cosecant x. The negative angle is given, then the trigonometric ratios will be like this. Okay, my dear children, understood? Right. Now come to the second point in the signs of trigonometric functions in different quadrants or as shown below. If the angle is in the first quadrant, then what is the trigonometric function's sign of that angle? Sign of the trigonometric function in the second quadrant, third quadrant, similarly in the fourth quadrant. Okay, my dear children, if the angle is in the first quadrant, then all trigonometric functions are positive. Okay, my children, come to the second quadrant. If the angle is in the second quadrant, then the trigonometric functions sine and cosine are positive and the rest are negative. Okay, my children, and if the angle is in the third quadrant, tan and cot are positive and the rest are negative. And if the angle is in the fourth quadrant, then cos and secant are positive and the rest are negative. Okay, my children, generally here we take 0 degrees or 360 degrees, 0 to pi, here 90 degrees, here pi by 2, 180 degrees or pi radians, here 270 degrees or 3 pi by 2 radians. These are called quadrant angles. 0, pi by 2, 180, 270 degrees. These are called quadrant angles. Previously we have discussed that point. Okay, my children? Right. Now come to this point, my dear children. An angle theta is said to be in the standard position if the vertex of theta is the origin and the initial side of theta is a positive x-axis. Okay, my children, this is the definition of standard position of an angle theta. I repeat this point, my dear children, listen carefully. An angle theta is said to be in the standard position if the vertex of theta is the origin, vertex of the angle theta is origin, and the initial side of the theta is a positive x-axis. Okay, my children? Right. Now come to the fourth point. An angle theta is said to be in the rth quadrant if the terminal side of theta lies in the earth quadrant where r is equal to 1, 2, 3, 4. Okay, my children, I repeat this point. An angle theta is said to be in the earth quadrant if the terminal side of theta lies in the earth quadrant where r is equal to 1, 2, 3, 4. We discuss these 2 points diagrammatically with the help of figures. Let us understand these 2 points, my dear children. Right. Now see this figure 1, first figure. Angle theta lies in the first quadrant. If an angle lies in the first quadrant, we draw a rough diagram like this. See this one. Here theta is in the standard position, means its initial ray is OM. OM is the initial ray. It is coinciding with the positive x-axis. Okay, my children. And theta lies in the first quadrant because its terminal or pi plus or minus theta. 360 degrees plus or minus theta or 2 pi plus or minus theta, and so on, etc. are called allied angles to the theta. If we take any angle plus theta or minus theta, the sum of these two angles, we get either 0 or multiple of 90 degrees. Understood this point, my children? Yes. Using trigonometric ratios of allied angles, we can find the trigonometric ratio of any magnitude. Understood, my children? Right.